Good evening, everybody. In this video lecture, we are going to analyze climate data for a specific location and use the online psychometric chart tool. So the objectives are, first of all, download a weather file for a specific location, for example, Beirut. Be able to convert the weather file into Excel spreadsheets in order to edit its content, analyze its content, and, for example, to calculate the average yearly temperature for the considered location. Then we are going to use the interactive psychometric chart tool, which is an online tool where you can upload weather data for any location and identify environmental design strategies that could be used in such location. In addition to this, you will be able to figure out web bulb temperatures and dew point temperatures for whatever climate condition. So weather data could be downloaded from, for example, the Energy Plus website, where you can find weather data for many locations. Unfortunately, Lebanon and Beirut are not included in the database. There is another database where you can find the weather conditions of Beirut. The ASHRAE database has different locations, including Beirut, but those files are not for free. You have to pay around $20 to $30 for each download. Regarding the Energy Plus, database, these are for free. For this exercise, we can consider Cyprus as location. So you can download the weather file of Cyprus and Cyprus Larnaca. So from the weather tool, the Energy Plus weather file, weather data, click on Europe. Then you will be directed to the Europe folder. You have Cyprus, which is Cyprus Larnaca, where the weather file of or weather conditions of Cyprus more or less could be similar to Beirut. It's a hot and humid climate. Click on Larnaca and you will be directed to the download folder. As you see, the weather file is available in different formats. Select the EPW format that is accepted by the online psychometric chart tool that we are going to cover later on. So click on EPW and start downloading the file. Once the file is downloaded, save it in an appropriate location that you will be able to find in order to upload the weather file into the psychometric chart tool. The file, as I mentioned, it's EPW extension, and the file name named by the city, which is Larnaca. This file will be accepted by as I mentioned earlier, by the psychometric chart online tool. But however, you are not able to view its content. In order to be able to view its content, you need to convert the weather file into the CSV format. So .csv, it's a file that could be opened by Excel. It's a spreadsheet, Excel spreadsheet. Energy Plus offers Energy Plus is a software, free software. From the Energy Plus website, click on Downloads and download the Energy Plus latest release. Actually, Energy Plus, it's a very powerful energy simulation tool. but we are going to use the interface that allows the conversion of weather files from the EPW format into the CSV format. So once you're finished with the download, double-click the .exe file in order to install Energy Plus on your computer. Once the install is done, you may not find the icon on the desktop of Energy Plus. Go to the apps in your computer and you will be finding Energy Plus, the different tools included in the package. We are going to use the weather statistics and conversion tool by Energy Plus. So click on the icon in order to run the tool. The tool has a very simple window where you have to select the file to convert. So you will be directed to the folder where the file was saved, the Larnaca EPW file. Then select the output format. For sure, you click the down arrow and you select the CSV format, which is the Excel spreadsheet. And then you click on the save file as. You will locate the file name and folder, the output file. For sure, the output is .csv, but you will assign a name and a folder for the converted file, and then click on the convert file. The process will take less than 3 to 4 seconds. Double click on the .csv weather file. So the Excel spreadsheet opens and you are able to see the content of the weather file. As you see, hourly climate conditions are saved, and as you see, so the first one is related to January 1st, 88. 88 is the years when the weather station captured the climate data. And here you have the dry bulb temperature, for sure for Larnaca, which is 9 degrees Celsius. You have the relative humidity values, 88. You have other interesting data, which are, for example, the amount of solar radiation falling on a horizontal surface, measured in watt hours per square meters. For sure, at 1 a.m. This is 1 a.m. The radiation is 0. Then you have starting from 8, 9, 10. Here you can see on the left hand the times. You can see the solar radiation. The peak is 761, which is between 12 to 13 p.m. In addition to this, you have as well the wind directions, for example. Sometimes we need to know the direction of the winds, especially if you are designing for natural ventilation. So here you have the direction for sure from north axis. It's not clear whether from north or south, but usually when we consider the azimuth angle, it's taken from north. So it appears that if it's from north, so 180 degrees from north, the prevailing winds direction, dominant or prevailing winds direction. And there are other data included in this weather file. So your first task is to calculate the average yearly temperature for Larnaca. And this could be done easily. Just select the column where you have the where you have the dry bulb temperature values. These are, as I mentioned, hourly values, resulting into 8,760 values, which is number of days per year multiplied by 24. Each day is 24 hours. So select the dry bulb temperature column. Okay, just using the shift key, you will select the data, and then from auto sum, click the down arrow and click average. Okay, automatically the average will be calculated, and which is 19.4 degrees Celsius. This is the average yearly temperature in Larnaca. We discussed in class the use of earth cooling, earth sheltering. These are strategies that uses the stable ground temperature all year round, which is equal to the average yearly temperature of the location. So in Cyprus, the average yearly temperature, Cyprus Larnaca for sure, the average yearly temperature is 19 degrees, which is close to the comfort temperature 21. This could be used in order to, in case of earth cooling strategy, you can use it in summer to during natural ventilation to improve the indoor comfort conditions. In Beirut, the average yearly temperature, I have the Beirut climate data file, and the average yearly temperature turned out to be 21 degrees Celsius. So it depends on the location, and it also shows us if specific environmental design strategies could be used. This is the layout of the Psychometric Chart online tool. It's available from the Andrew Marsh website, andrewmarsh.com psychochart. Okay, you can access the tool, and you have to click on the Launch App in New tab. Okay, this is the software that allows to use the interactive psychometric chart. You don't need to download it, you just use the tool within the server. So it's an online based tool. No need to download any software, but you need an internet connection. This is the layout of the psychometric chart. As I mentioned earlier, it allows to visualize the climate data conditions on the psychometric chart, and to include the Giovanni bioclimatic chart, which is the comfort conditions overlay, and to see how many hours per year you have comfort climate conditions, for what climate data evaporative cooling could be used as strategy, as well heating in winter. You have as well how many hours per year heating is needed, how many hours per year passive solar heating could be sufficient in order to achieve comfort conditions. And for how many hours you have comfort conditions where no heating or cooling are needed. So click on the Launch App in New tab to run the tool. Okay, if you have a pop-up blocked, you have to reactivate or resolve the problem. In this case, I have to allow. And then I'll try again. Okay, as I mentioned, it's a tool which is web-based, so you need an internet connection, reliable internet connection. No need to download any software. This is the app. You have the psychometric chart. As I mentioned in the lecture, in a previous lecture, on the horizontal axis, you have the dry bulb temperature in degrees Celsius. The curves represent relative humidity levels, and these range from 40%, 30%, 20% to 80, 90, 100. 100 is a fully saturated air with 100% relative humidity. The pointer here, the red pointer, represents a specific climate condition. So in this case, it's a climate condition characterized by a dry bulb temperature 23 degrees Celsius and a relative humidity 40%. I can change the pointer location, for example here, where I have 27 degrees Celsius temperature. I need to draw from the point a vertical line and read the value on the horizontal axis. As well, the value is displayed here in the indicator paragraph. On the left hand, I have editing section. For example, I can display wet bulb temperatures. And as you see, you have the oblique lines that identify the wet bulb temperatures. As I have mentioned in class, the wet bulb temperature is the temperature measured at saturation when you have relative humidity 100%. For example, if I locate the pointer here, a climate condition with 44 degrees Celsius dry bulb temperature, which is the atmosphere temperature, the air temperature, and a relative humidity 100%. The dry bulb temperature for this specific condition is measured or read on this line. So I have to draw a line from this point parallel to the wet bulb temperature lines, and the wet bulb temperature, as you see, is 25 degrees. And you can also see the value here, highlighted here in this paragraph. So wet bulb temperature is the temperature measured at saturation. So if any climate condition at saturation will have a dry bulb temperature equal to the wet bulb temperature. So in this case, with this climate condition, the dry bulb temperature is 22.5, which is equal to the wet bulb temperature. As I have mentioned in class, the wet bulb temperature is used to assess the effectiveness of evaporative cooling, and usually is measured with a thermometer covered with a wet sock. A wet sock to imitate 100% relative humidity, a fully saturated air. So let's consider again a volume of air at a 40% relative humidity. So this is the 40% relative humidity curve, and dry bulb temperature 29 degrees, 29.5, which is this point here. So 29.7 relative humidity, dry bulb temperature, and relative humidity 40%. The values are also displayed here. The evaporative cooling process is when you introduce water vapor or when water evaporates within an air volume. When water evaporates, the heat of vaporization is taken from the air, so the air temperature drops. Its relative humidity increases, its absolute humidity increases as well. The absolute humidity is displayed on this vertical axis and represents the actual amount of water vapor content within a volume of air. So when water evaporates within the air volume, automatically relative humidity will increase and the absolute humidity increases as well. The line that should be followed is this oblique line, and we can see that the air temperature drops. So the evaporative cooling process will cause absolute humidity to increase, relative humidity to increase, and the air temperature decrease until the volume of air reaches saturation. At saturation, no more evaporative cooling, or the volume of air can't bear more water vapor content. Its relative humidity is 100%, and the dry bulb temperature is equal to the wet bulb temperature, in this case 20 degrees Celsius. Now we are going to upload the weather conditions of Larnaca, the file that has been downloaded earlier. So we need to click on data mapping to extend the section. Load EPW, so the weather file that has been downloaded. You have to allocate or go to the folder where the file was saved. So this is the file that has been recently downloaded. Open. Okay, the weather file, the climate data has been imported into the psychometric chart, the hourly climate data of Larnaca. I want to change the display. So it's a combination of dry bulb temperature and relative humidity values that are going to display it as hourly data, so hour per hour, and I will click update chart. So these are the hourly climate conditions in Larnaca for during 1 year. So the points represent hour per hour climate conditions in Larnaca, the blue points. The total number of the dots is 8,760 hours, which is the total hours in 1 year, total number of hours in 1 year, which is the result of 360 days multiplied by 24 hours. As I mentioned earlier, we can also use this chart to figure out for how many hours during a year comfort conditions are met, so no heating or cooling are needed, no heating or cooling is needed. We can as well see the environmental design strategies that could be implemented in our building design, such as natural ventilation, evaporative cooling, passive heating. So in the comfort overlay, select the Giovanni bioclimatic chart, and you have display of the bioclimatic chart on the psychometric chart. The mean outdoor temperature by default is 19 degrees, which is the temperature that was identified earlier, so no need to change the value since it's the mean outdoor temperature for Larnaca. To remind you, I will reopen the Excel sheet file and show you that the mean temperature for 1 year, during 1 year, average yearly temperature is 19 degrees. Okay, so this value should be set to the correct value since it will change the chart allocation, and I will keep it 90 degrees Celsius. We can see from the chart that in Larnaca, outdoor temperature below 5 degrees may occur, and heating is needed. For the rest, active solar heating and passive solar heating could be implemented in order to meet comfort conditions. Some climate conditions, internal heat gains could be sufficient to meet comfort conditions. In the comfort zone, also, we have consistent number of hours where no heating and cooling are needed. Natural ventilation in summer could be sufficient for consistent number of hours. Evaporative cooling could be used, however, the number of hours for evaporative cooling are not quite a large number. We know Larnaca is a humid climate similar to Beirut, and there are also a number of hours where you need air conditioning. I am going now to upload the climate data of Beirut. I have the file saved on my computer, so I will go to the weather file of Beirut, and it's an EPW file as well, extension EPW. I'll open the file, and you can see that it changed. The appearance changed. Beirut has a different weather than Larnaca. We can see that passive solar heating is enough in order to meet comfort conditions. Active solar and mechanical heating, there are no hourly climate conditions that falls in this area. Most of the climate data and the hourly values are within the passive solar heating. The comfort zone also has a consistent number of hours. Natural ventilation in summer as well could be used to achieve comfort conditions. There is a number of hours where mechanical air conditioning is needed for sure, and evaporative cooling for some time could be used. We know that similar to Larnaca, Beirut climate is a humid climate, so evaporative cooling use is quite limited. For sure, the allocation of the zones depends on the average yearly temperature that is not 19 degrees in Beirut. You need to change the value to the correct value, and actually it's 21. I have already calculated the value for Beirut. It's 21, the average yearly temperature in Beirut. So this is the correct allocation of the chart. However, it changed little. We have 1 hour where active solar heating is needed. However, but it is similar to the previous analysis. Mainly, we need passive solar heating could be sufficient in order to meet comfort conditions in winter. Natural ventilation as well in summer. Some evaporative cooling and some air conditioning. Here we can see a zone called mass cooling. It could be referred to the thermal mass cooling. We know thermal mass cooling or heating is used in locations characterized by temperature fluctuation between day and night. So the heating taken during daytime by the thermal mass is given off during night by night ventilation and night cooling. So it needs weather conditions with temperature fluctuation between day and night, which is not doesn't happen always in Beirut. There are some locations, and we have seen case studies. For example, in Sydney, Australia, we have seen a building where they have used thermal mass, and between 1 to 5 a.m. In the night, the temperature drops and night cooling could be used. So there's fluctuation between day and night temperatures. Let's take into consideration climate condition within the evaporative cooling zone. So this climate condition here, where you have temperature, dry bulb temperature around 29 degrees Celsius and low relative humidity level 26%. I will turn on the wet bulb temperature lines. Okay, following the wet bulb temperature lines, the evaporative cooling strategy can bring this condition into the comfort zone by water evaporation within the airflow, and could, for example, achieve a dry bulb temperature of 24 degrees Celsius with a relative humidity 50%. So the relative humidity increased and the dry bulb temperature dropped. This is the evaporative cooling concept. When you add water vapor content to the airflow, dropping down the air temperature. If you proceed, okay, then saturation occurs. For sure, here we are outside the comfort zone. And the minimum temperature that could be achieved by evaporative cooling is 18 degrees with 100% relative humidity. So you have around 11 degrees temperature drop from 29 to 18. I will consider now an indoor climate condition. Okay, so the blue dots are outdoor climate conditions registered over 1 year and represents hourly climate conditions. I'm just going to consider an indoor climate condition during winter when heating is used and the thermostat temperature is at 21 degrees. This is the line 21 degrees. And our relative humidity indoor could be as high as 80%. Okay, depends on the number of occupants indoor. Depends as well whether there is cooking, different aspects that can affect the relative humidity indoors. So between 80 to 70, and with thermostat temperature set at 21 degrees Celsius. So 21 degrees Celsius, dry bulb temperature, relative humidity 60%. I covered in class the dew point temperature definition, and I mentioned that it's the temperature at which water vapor condensation occurs. So volume of air is cooled down until it reaches saturation, and the temperature when its relative humidity is 100% is called dew point temperature. So it's the temperature at which water vapor condensation occurs. For this thermal condition, as I mentioned, 21 degrees dry bulb temperature and 63% relative humidity, the dew point temperature of this volume of air is 14 degrees Celsius. So when the volume of air is cooled down to 14 degrees Celsius, then water vapor condensation occurs. We can use the chart to figure out the dew point temperature by drawing a horizontal line from this thermal condition, the thermal condition for which we want to see and figure out the dew point temperature, a horizontal line, and it's a process of cooling. When you cool down the air, it will move parallel to the horizontal axis, the dry bulb temperature axis. Its absolute humidity is stable, so there is no humidification or dehumidification. It's cooling down, so its dry bulb temperature drops until it reaches saturation. Saturation at 100% relative humidity curve, and here you can read the dew point temperature, which is 14 degrees. The dew point temperature is equal to the dry bulb temperature at saturation. It's a fully saturated air, and you can see as well here the value displayed, 14 degrees dew point temperature. So by drawing a horizontal line until it reaches saturation at 100% relative humidity curve, you identify the dew point temperature. So tasks that you are going to perform and are listed in the final slide are identify a climate condition within the evaporative cooling zone, for example this point here, and let's call it point A. So this is A. From this point, by evaporative cooling, I can bring the climate condition into into the comfort zone. I will call it point B. In point B, the dry bulb temperature that could be achieved is around 24 degrees Celsius with a relative humidity, and the relative humidity curves are these curves, so you have to follow the curve and read the relative humidity value, which is here 50%. Okay, so it's within the comfort zone. The evaporative cooling is following this oblique line that brings a point A outside the comfort zone, an outdoor air condition, into the comfort zone by evaporative cooling. And some of you have already discussed case studies where evaporative cooling implemented, and the buildings are characterized by the cooling towers that brings the air from the top, and they have microscopic water spray that sprays microscopic water drops into the airflow. Water, by evaporating within the airflow, takes the heat from the air and the air temperature drops. On the psychometric chart, the shift between A and B represent cooling down the air by evaporative cooling. The relative humidity increases, the air temperature drops, and there is another thing, that the absolute humidity, which is on the vertical axis between points A and B, also increased, since water vapor content is added to the air volume. Next, you have to show the wet bulb temperature, so you have to proceed with the line until the volume of air reaches saturation and it's point C. The point C, you have 100% relative humidity value, 100% relative humidity. and the wet bulb temperature is equal to the dry bulb temperature in this case, and it's around 18 degrees Celsius. Okay, so this is the point where you read the temperature value. Also here you have a scale of the wet bulb temperature. Okay, so it's between 15 and 20. Regarding the dew point temperature, we are going to consider climate condition that occurs indoors with a 21 degrees Celsius dry bulb temperature and a relative humidity following the 50 or 60% curve. Okay, around 60 to 50%. 60 is here. Okay, so point C. Identify point A, let's call it point A, and A is the thermal condition with dry dBT stands for dry bulb temperature 21 degrees Celsius and relative humidity 60%. This is an indoor climate condition, so it's not the blue dots represented on the psychometric chart. The blue dots represents hourly climate conditions that occurs outdoors. So it's the outdoor climate conditions. Point A, which is a climate condition with 21 degrees Celsius dry bulb temperature and relative humidity 60%, has a dew point temperature. To identify the dew point temperature, as I mentioned earlier, you have to draw a horizontal line, and it's the process of cooling down the volume of air. The volume of air is cooled down by touching a cold surface, and this is what occurs in winter when you have water vapor condensation on the glass pane in your car or at your house, especially in kitchens when relative humidity levels are high. You have water vapor condensation on the glass pane. Let's see how much is the dew point temperature. So when the volume of air reaches saturation, this is the point where you can read the dew point temperature. I need to draw a vertical line, and it's 14 degrees Celsius, the dew point temperature. Okay, the values that I have figured out using the graph are also automatically displayed by the tool. So I have the dew point temperature around 14 degrees Celsius. However, we have to know how to use the chart and to figure out the different temperature, whether wet bulb or dew point temperature. And this is very important. For example, an indoor air inside a building which touches a cold surface, as I mentioned, the glass, or within a wall or roof assembly, when the air diffuses through the wall or roof assembly by exfiltration. We are going to cover this soon. So water vapor condensation may occur within the wall assembly. So this is very important to know the dew point temperature of a volume of air. And in Lebanon, as we see, the 14 degrees Celsius temperature in winter will be met, and you have consistent number of hours below the dew point temperature. For all these thermal conditions that I circled here, the atmosphere or outdoor temperature is below the 14 degrees Celsius, which is the dew point temperature of this volume of air, characterized by a dew point temperature 21 degrees Celsius and 60% relative humidity, a typical indoor air condition in winter. Okay, so water vapor condensation will occur for a consistent number of hours during winter. That's why precautions during the construction of wall and roof assemblies should be done by installation of vapor barriers that stops water from reaching the cold surface of the assembly. And this topic will be discussed in the next lectures. It's a very important topic that considers the design of wall and roof assemblies. So once you are done by the video lecture, once you finish the video and you understood the material covered in the lecture, you are requested to develop the following material. So the weather file that you are going to download, you are requested to convert it into the Excel format and calculate the average yearly temperature of the location. You may refer to the Larnaca weather file, which is available free of charge, or if you want, if you would like, you can also purchase the weather file of Beirut. This material should be uploaded on Blackboard. Screenshots of the psychometric chart with the weather file uploaded, and you have the opportunity to upload whether Larnaca or Beirut weather file, and the environmental strategies highlighted, the comfort zone and the other zone that are shown on the psychometric chart. Then identify a climate condition within the evaporative cooling zone. The exercise that I have done right now. Figure out the wet bulb temperature, figure out the effectiveness of evaporative cooling. So as I mentioned earlier, from point A to point B, when you shift from the evaporative cooling zone into the comfort zone, identify the dry bulb temperature and relative humidity values of point B and then point C at saturation. Then identify a climate condition within the comfort zone and figure out its dew point temperature. Okay, for sure you have to show the process on the psychometric chart. So you have to print out or use the psychometric chart and draw on the psychometric chart. You may print out the chart, draw on the chart and scan the image. Scan your drawing and then upload it on Blackboard. You can as well use Paint or Photoshop to draw the lines and show the different climate conditions. By the way, this chart here that I have saved could be saved from the online tool. I will go back to the online tool. Okay, by right-clicking on the tool, you can save the graph or print it. Okay, so try either. You can print it as PDF or you can save it as well. No, here you save it as a web page. Printing it will be more useful, so you can print it as PDF and then you can convert the PDF into image. You can print the PDF and draw directly on the PDF, and then you can draw directly on the printed sheet and scan it and upload it on Blackboard. Okay, going back to the requirements. Okay, 5, I would like if you can write down a discussion paragraph regarding the environmental design strategies that could be used for cooling and heating according to the weather conditions. So a discussion of the cooling and heating strategies according to the weather conditions of the location. You may, as I mentioned earlier, you may consider Larnaca or Beirut and discuss the strategies that are already shown in the psychometric chart. So if you consider, for example, Beirut, so what are the strategies used during winter? What are the strategies used during summer? A summary of what is represented on the psychometric chart with the different environmental strategies, from natural ventilation to evaporative cooling to passive heating. So I will create a task folder, an assignment task folder where you can upload your documents. And it's very important that you can, as I mentioned in the last point, you can group your outputs into a single word file where you can put the screenshots, the scanned images with your sketches on them, and the discussion paragraph in a single file instead of uploading multiple files. However, the way you feel better, how you organize your submission is also, you can use the way you feel more appropriate.